infinite limits versus limits at infinity. So these are two different things. Okay? Infinite limits says that the limit of f of x as x approaches a is positive or negative infinity. This is an infinite limit. The answer is positive or negative infinity. Limits at infinity means limit as x approaches infinity or x approaches negative infinity from f of x. So these are two different things. These normally trigger vertical asymptotes, if they exist. This normally triggers horizontal or slant asymptotes. So this is basically for the end behavior, so-called end behavior of the function. This one deals with behavior near vertical asymptotes.
I have a question.
Yes.
You wanted us to submit our notes to the class upload.
Yes, for the 10th, for February the 10th, yes.
We just resubmit each time, because for me it's showing 2 February 10th class uploads.
Maybe you submitted by mistake last time. It's okay. It takes more than one upload. Yeah. There is no restriction on the uploads. Okay. So understand the difference between these two. For now, we're going to talk about this piece. Very soon, we're going to talk about this piece. But for now, we're going to talk about this piece. Any questions for me? Sorry for muting you. It's for the noise, the background noise. Okay. So let's look at limit of, 1 over x minus 2 as x approaches 2 from the right. I'm going to erase this. Don't copy this. I'm going to use the my best friend, the whiteout. So x approaches 2 from the left of 1 over x minus 2, and then the limit as x approaches 2 from 1 over x minus 2. I got carried away. Okay, so every time we calculate limits, number one, plug it in. And you can say, what do you mean by plug it in? You just told us that x does not equal 2, and now you want me to plug it in. Which one is it? Yes, I agree there is a contradiction in that, but I have to plug it in because I need to see what type of limit this is. Although x approaches 2 clearly says x does not equal 2, I still have to plug it in. And when I plug it in, the numerator is 1. What do I get in the denominator when I plug in 2?
More than 0?
If you want, but it's 0. Okay. I'll come back. There are two situations to keep in mind here. So one situation is a number over 0, not 0. This is no hope that the limit exists. Impossible. This is what it's called undefined. The limit will not exist. And what are the options here? 3 possible options: infinity, negative infinity, or DNE, carved in stone. There is a second possibility of 0 over 0 or infinity over infinity. And here there is hope. I'm not saying it's guaranteed. I'm saying there is hope. It may still not exist. The limit may not exist, but there is hope. In 0 over 0, infinity over infinity, there is hope. And other situations, but these are what we discussed right now. There are 7. These are called indeterminate. Indeterminate, not undefined, indeterminate cases, and there is a total of 7. We don't know what to expect. It can be 0, it can be -5, it can be natural log 3, it can be infinity. So these are 2 out of 7 indeterminate cases. I'm only saying it is possible. I'm not saying there is a guarantee. But look what we obtained. We obtained a no hope situation. So these are the possibilities right now. And as who was that who answered? One of your colleagues said a little bit more than 2. He's right. Because a little bit more than 2 minus 2 will be positive. So this will be, you don't have to write positive, I'm just making a point. It's positive infinity. Why? Because it's a number over 0. And there is no hope. And it has to be one of these 3, carved in stone. It could be oscillating, but it's still DNE or some other situation, but they're all 3. Same thing here. When I plug it in, I still get 1 over 0. There's no discussion. But now, what do you think the sign will be? So when you plug in 2 from the left at this point, you know it's infinity, but now you're plugging in 1.9, a number to the left of 2. What will be the sign here?
Negative infinity.
Right. And now we will draw a conclusion based on these 2. And of course, we will write that x equals 2 is a vertical asymptote. So what will you write for limit from either side?
Undefined.
We cannot write undefined for limits. We can write for functions.
Does not exist.
Exactly. Exactly. Very good. So here another example of an infinite limit. Any questions on this? Let's stop for a moment. Any questions? This is very important. Okay. Yes? Yes?
Can you move back up to the traits of infinite limits and
Yes,
limits?
just give me 1 second so I can plug in my device because it's running out of juice and then I may lose you. Okay, so now it's plugged in. So what am I saying here? Or what am I doing?
Could you just quickly move the paper up so I can see what's under infinite limits and limits? And yeah, I can just take a picture and write that stuff down.
Sure, yes. I will post this. I will post this right after class. You know where to find those, right?
Where can we find it?
Okay, yeah. Let me share my screen. Let me get to your class. Let me share my screen. Where are you guys? I lose you sometimes. And all these windows open here. Sorry about that. You go to modules. Remember, if you want to see any of this ahead of time, you have 5 or 6 previous semesters. Okay, right here. Spring 2021, fall 2020, blah, 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 all of these. And yours are, and also fall 2021. Why isn't this closer here? It just got messed up there. I have to move it. So at the very top, you have the written homework, blah, blah, blah. And this is what we did last time. Part 1, Part 2, Part 3. So right here, right after class tonight, I will post all the videos. Will be more than 3 because last time I talked about the syllabus too long. And lecture notes. And for the videos, they all work. I check them before I delete them from my hard drive on the other device. And don't say, oh, they don't work. Many of my students, I get emails, oh, they don't work. Well, they're up here. Okay? So they're about 20 minutes long or less. So I eliminated that light on the right-hand side, so this should not happen again. Okay? So I'm sorry. The next one is, you know, they'll see the other class, it worked because I removed that lamp on the side. No, I don't want any trial. I don't want anything. Okay? So they will be posted right after class. It takes a while for me to upload. So it's not going to be instantaneous, but within an hour, you should be able to see them. The notes first and then the videos. Okay. I would like to quickly look at the natural log function and the exponential function. So please carve this to your memory. This is the graph of the exponential function e to the x, natural exponential function. Okay, so limit s, I shouldn't do this right now because okay. Yeah, I messed up. I really wanted the natural log because we haven't talked about this, but since I have it here now, I have to put it. So an x approaches infinity of e to the x. It's okay. I'm going to come back to it, but I really wanted to talk about the natural log. But so we haven't talked about this. That's why I put that function, but I can't go back and say no. So we haven't talked about this just yet. We only talked about this. So the natural log is an example here, and the exponential is an example here, but I wrote it, so allow me to finish it. So as x approaches infinity, the function values get closer and closer to what? Where are they going?
Would it be infinity?
Absolutely.
And beyond.
Good. And then the other side, e to the x, as x approaches negative infinity. We'll come back to this function. So now let's take a look. As x approaches negative infinity, the function values get closer and closer, closer and closer to
Zero.
excellent. So that's why y equals 0, as we see. It's a horizontal asymptote. My apologies, I didn't want to show this example, but since I put it up there, I had to talk about it. So we'll come back to that, because that's, as I said, this is this. I want you to see that there are two different things, one for specifically, I would say, or mainly for vertical asymptotes, and the other one for horizontal asymptotes. Okay, so I meant to look at the natural log. So please carve this to your memory. This is the graph of natural log x, symmetric with respect to y equals x of that graph. So natural log x, they are inverses of each other. And this of natural log x, of course, as x approaches 0 only from the right. The function does not exist from the left. So 0 from the right. What will you say?
Is it 0?
So don't say anything before you follow the function. As x approaches 0 from the right, the function values
negative infinity.
That's why x equals 0 is a vertical asymptote. Okay, I'm just gonna go back to the book, sharing my screen. Okay, I want to look at some graphs with you. Sorry guys, you're in the way. Okay. Okay, am I in 2-2? Yes, I am in 2-2. Yes, let's start with this graph. And let's see. Okay, jumps sometimes. Okay. Okay, we are asked a lot of questions for the function blah, 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 blah. I'm going to ask them without even looking. Okay, so let's start with -3. Here's -3. Can anyone give us the limit from the left of -3?
Is it 4?
Absolutely. 1, 2, 3, 4. The limit from the left of -3. Function values, follow the function, follow the function, follow the function, going to 4. How much is f of -3?
Doesn't exist.
Excellent. We like to say undefined for a function, but I accept fully. Does not exist. The limit from the left of 0. Stop me if you have questions, please. The limit from the left of 0.
1.
Perfect. The limit from the right of 0.
-1.
The limit from either side of 0.
Does not exist.
Excellent. F of 2.
So if it ends at an open dot, it doesn't exist?
The
Okay.
limit. You are talking about the limit?
Yes.
Okay, let's go back. The limit from either side exists only if the limit from the left exists, the limit from the right exists, and they're absolutely the same number.
Oh yeah, it has to come from both sides.
And this is from both sides. Better?
Yes.
Perfect. Good. So that's why the limit from the left is 1, the limit from the right is -1, the limit from either side does not exist. You already told me f of 2, undefined. The limit from the right of 5, the right of 5.
Is that 3 or 2?
Very good.
Oh, 3,
It is
not 3.
3. Yes, 1, 2, 3.
Sorry, I was getting mixed up.
Perfect. 1, 2, 3. Perfect. Now the limit from the left, as you see, it's all over the place. It's oscillating. So that means that the limit does not exist from the left. And from the other side also does not exist. Okay? It's an oscillating limit. Okay. The limit from the left of -3.
Positive infinity.
Excellent. The limit from the right of -3.
Positive infinity.
Excellent. The limit from either side of -3.
Positive infinity.
Excellent. That's it. What about at 2? The limit from the left of 2.
Negative infinity.
Excellent. The limit from the right of 2.
Positive infinity.
And the limit from either side of 2.
Does not exist.
Yes. Thank you, Kelsey. Excellent. Okay, what can you say about the line x equals -3?
Vertical asymptote.
Excellent. What can you say about x equals -1?
It's also vertical asymptote.
Excellent. What can you say about x equals 2?
It is also vertical asymptote.
Excellent. I'm jumping ahead since I showed you by mistake e to the x. As x approaches -infinity, where will the function values go?
Zero.
Yes. What does